presence of ethanol recirculation systems in the cleanroom may require a reclassification of the area from its current ISO 7 status to a more hazardous classification, such as Class 1, Division 1, Group D. This is because ethanol is a flammable liquid, and its presence in the cleanroom can significantly increase the risk of fire or explosion. Considering electrical equipment requirements, it is important to note that all electrical equipment installed in a hazardous location must be appropriately rated for the specific class, division, and group of that area. NEMA 7X is considered a high rating for electrical equipment intended for use in hazardous locations. It provides robust protection against explosions that could be caused by the presence of gas, dust, or fibers, which includes flammable vapors. Therefore, it is highly likely that all electrical equipment within the cleanroom, including the machines and any hookups, will need to be rated NEMA 7X or equivalent to meet the requirements for a Class 1, Division 1, Group D hazardous location. In this classification, Class 1 refers to locations where flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Division 1 indicates that the hazardous material is present continuously, intermittently, or periodically under normal operating conditions. Group D includes flammable liquids such as ethanol, gasoline, acetone, benzene, butane, propane, alcohol, and lacquer solvent vapors. Air circulation alone may not be sufficient to provide adequate fume removal to prevent explosions. The decision to not include secondary containment for one of the largest systems introduces additional concerns. Proper ventilation and fume removal systems must be carefully designed and installed to maintain a safe level of ethanol vapors within the cleanroom. This may require the use of exhaust fans, strategically placed ductwork, and other measures designed to effectively remove flammable vapors from the area. These measures help to prevent the accumulation of dangerous concentrations of ethanol vapor which could lead to a fire or explosion. Additional considerations are also important to keep in mind. Firstly, training is crucial. All personnel working in the cleanroom must receive thorough training on the hazards associated with ethanol and on the safety procedures that must be followed. This training should cover topics such as the proper handling of ethanol, the use of personal protective equipment, emergency procedures, and the operation of safety equipment. Secondly, an emergency response plan should be developed and implemented. This plan should outline the steps to be taken in the event of an emergency, such as a fire or explosion. It should include procedures for quickly evacuating personnel containing any incidents and contacting emergency services. Regular drills and exercises should be conducted to ensure that personnel are familiar with the plan and can respond effectively in an emergency. Thirdly, compliance is mandatory. The cleanroom must comply with all applicable codes and regulations for hazardous locations. This includes national, state, and local regulations as well as industry standards. It is important to stay up to date on these regulations and to ensure that the cleanroom is in full compliance at all times. It is highly recommended to consult with a qualified expert, such as a certified safety professional or a licensed electrical engineer with experience in hazardous locations, to conduct a thorough assessment of the specific risks involved and to determine the appropriate code classification, electrical equipment requirements, and fume removal measures for the cleanroom. These professionals can provide valuable guidance and ensure that the cleanroom meets all applicable safety standards. The National Electrical Code, also known as NEC, provides detailed requirements for electrical installations in hazardous locations. Articles 500 through 516 of the NEC cover the classification of hazardous locations and the requirements for electrical equipment installed in those locations. These articles provide guidance on selecting the appropriate type of equipment for a given location, as well as on the installation and maintenance of that equipment. The NEC also includes tables that specify the minimum distances that electrical equipment must be located from potential sources of ignition. These distances are designed to prevent explosions by ensuring that electrical equipment cannot ignite flammable vapors or gases. Some specific requirements include ensuring that all electrical equipment is properly grounded to prevent static electricity buildup, using explosion-proof fittings and enclosures to contain any explosions that may occur, and installing interlocks to prevent equipment from operating if the ventilation system is not functioning properly. The Occupational Safety and Health Administration, also known as OSHA, also has regulations that apply to hazardous locations. OSHA's regulations cover a wide range of topics, including hazard communication, personal protective equipment, and emergency response. OSHA also has specific regulations for certain types of hazardous locations, such as those involving flammable liquids or gases. It is important to be familiar with OSHA's regulations and to comply with them at all times. The American National Standards Institute, also known as ANSI, also develops standards for hazardous locations. ANSI standards cover topics such as the design, construction, and testing of electrical equipment for hazardous locations. ANSI standards are often referenced in the NEC and OSHA regulations. It is important to be familiar with ANSI standards and to comply with them when designing, constructing, or installing electrical equipment for hazardous locations. Consider the specific properties of ethanol when evaluating the risks. Ethanol is a flammable liquid with a relatively low flash point, meaning that it can easily ignite at room temperature. Ethanol vapors are also heavier than air, which means that they can accumulate in low-lying areas, creating a fire or explosion hazard. When evaluating the risks associated with ethanol, it is important to consider these properties and to take appropriate precautions. Consider the potential for leaks and spills. Ethanol can be released into the environment through leaks or spills. These releases can create a fire or explosion hazard, as well as environmental contamination. It is important to have procedures in place to prevent leaks and spills, and to respond quickly and effectively if they do occur. This includes using appropriate containers and equipment for handling ethanol, providing secondary containment to capture any spills, and having spill response kits readily available. Consider the potential for static electricity buildup. Ethanol is a non-conductive liquid, which means that it can easily build up static electricity. Static electricity can create a spark that could ignite flammable vapors or gases. It is important to take precautions to prevent static electricity buildup, such as grounding all equipment, using conductive containers, and wearing static dissipative clothing. Consider the potential for chemical reactions. Ethanol can react with other chemicals to create hazardous conditions. For example, ethanol can react with oxidizers to create an explosion hazard. It is important to be aware of the potential for chemical reactions and to take appropriate precautions. This includes storing ethanol separately from incompatible chemicals, providing adequate ventilation to prevent the buildup of hazardous vapors, and using appropriate personal protective equipment. To summarize, the classification of the cleanroom will depend on several factors, including the quantity of ethanol present, the ventilation system, and the electrical equipment installed. It is important to consult with a qualified expert to determine the appropriate classification. Electrical equipment must be rated for the specific class, division, and group of the hazardous location. NEMA 7X is a high rating for electrical equipment in hazardous locations. Proper ventilation and fume removal systems must be designed and installed to maintain a safe level of ethanol vapors in the cleanroom. Personnel working in the cleanroom must be properly trained on the hazards of ethanol and on safety procedures. An emergency response plan should be in place to quickly evacuate personnel and contain any incidents. The cleanroom must comply with all applicable codes and regulations for hazardous locations. Consulting with experts ensures proper assessment and safety.